What's up, everybody? This is your boy Tech G back with another video to help you successfully pass the CompTIA A+ 220 1102 certification exams. So let's get into it. In this video, you're going to learn about the basics of scripting. PC technicians are often called upon to work on, configure, and update many computers or other devices at one time. And that can mean repeating the same tasks on each machine, waiting for long processes to run or updates to install on each machine. This can take a lot of time. Writing a script with all the commands and inputs, this allows you to run updates automatically, which can save you some valuable time and, more importantly, some money. Programming is an important technical skill, but it is beyond the scope of the A+ exam. However, being able to identify the basics of scripting is important because the capability to run scripts as a PC technician or an administrator is an invaluable asset. All right, so let's talk about script file types. So script files, these are text files that contain instructions or commands that a computer follows to perform a task. They can be straight text commands for an operating system, or they can be written in a scripting language, which is a limited kind of programming language that can be run on the computer and interpreted by the operating system. The operating system then performs the commands in the script to complete the task. And this table on your screen here, this identifies and briefly describes the 6 common scripting languages required for the A+ exam. So you should be able to recognize them by their file extension type. Scripts can be opened and read or edited in basic text editors such as Notepad, or in special programming environments that assist with commands and testing of scripts. These are often referred to as shells, and they are designed to assist in script writing. Let's talk about some use cases for scripting. So the purpose of scripts is to automate tasks commonly performed by a technician. Using tasks saves time, not only in typing out the script, but also in ensuring the reliability of the input and avoiding unintended consequences from bad code. In this table listed on your screen here, this lists 7 common use cases where scripts are useful. All right, so let's talk about some other scripting considerations. So a common frustration for people new to scripting is fat fingering a script with the wrong character or number, and having even this type of small error cause the script to fail. All computer languages follow strict command structures and syntax. Although shells take away some of the burden, syntax still needs to be correct. When entering a script into a production environment, you want to be sure that it has been tested in a sandbox environment first. Not doing so could result in harmful effects on the production network, such as unintentionally introducing malware. And this can be done by not checking imported scripts with security software or inadvertently changing system settings. So remember that computers do not question what they are told to do. If bad scripting instructions change security or other system settings, this could open the door to disaster. Or a browser or system crashes due to the mishandling of resources. So sometimes a poorly written script, this can instruct the computer to run a task that is beyond the power of a machine to handle. If the CPU is busy running a loop in a bad script, it doesn't have resources for other important tasks. So again, sandboxing, this should prevent these types of errors. All right, so this was my quick video where we talked about the basics of scripting.